Welcome to myprojectbazaar.com. Let we discuss about the process, a speed up scheme based on multiple instance pruning for pedestrian direction using a support vector machine. Let me see the abstract of the process. In video surveillance applications, main aim will be the identification of pedestrians, that is the position of the persons in each frames of the video. Tracking of the abstract motions is a challenging task in computer vision's SVM classification combined with HOG features were proposed for effective handling the local trap problem, that is identification of the individuals. The classification methodology is employed for the identification of the foreground regions in the video frames. The features were extracted using COHOG feature extraction methodology, which gives us knowledge about the intensity-based informations from the images. The performance of the processes were measured in terms of the accuracy error rate, like that. The pedestrians in the video frames were detected based on object-based detection methodology. First, the positions of the objects in the videos were identified using background subtraction method. After that, the morphological operations were employed for segmentation of the objects in an efficient manner. Finally, the detected regions were estimated based on the SVM classification methodology for extracting the HOG feature extractions from the images. The intensity related informations from the obtained pixels were got using the HOG feature extraction methodology. SVM is a supervised learning method that classifies the input data vector into different categories. In our proposed methodology, the data vector is classified as object regions and the background regions. So the estimated object regions from the background subtraction methodology is clearly obtained from the SVM classification. The regions that were identified as the background were given as similar representations, and the regions that were identified as objects were given as similar representations. Here the similar representations means zeros, providing zeros and ones in all the sequences. The overall performances of the processes were measured by identification of the object positions in an accurate manner when compared to the existing methodologies used for the identification of the object pixels in the videos, which is based on other feature extraction methodologies and object related informations extracted from the video frames. Let me see the flow of the process. In this process, the input is the video frames that is present in the dataset. In this process, we have to employ background subtraction, and hence the video has been designed so that the first frame of the videos contains the empty background of the whole sequence. Hence the process will be exact for the videos given by us. The videos were converted into frames. In this process, the overall frame height and width in the video is calculated, and based on that the video is converted into frames. Then we employ the background subtraction process. In this process, each frame is subtracted from the reference empty background frame in order to remove the background regions present in the videos. After the subtraction of the background, the object coordinates were estimated. After that, the features were extracted from the frames using COHOG feature extraction methodologies. In this process, the overall intensity informations in the images were obtained from COHOG feature extraction methodologies. In this process, the input video frames were divided into small regions, and in each regions, the histograms of the orientation were assigned, and the values were extracted as the features. So the extracted features were given as input for the classification methodologies. So in the classification methodologies, the input video estimated frames were classified as object or background. The background subtracted frames were morphologically optimized in order to obtain the exact object informations from them. So the identified values were then estimated based on the SVM classification methodologies. So the obtained object positions from the morphological operations were selected as the object pixels. They were then subjected to tracking. Finally, the overall performances were measured in terms of accuracy, sensitivity, and specificity of the overall process. Let us see the running procedure of the process. If you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on Run File. You will get the user interface. So this user interface contains the buttons and the display accesses for the execution of the process. So select any one of the video which is present in the dataset. So if we give any one of the videos will be loaded and it will be displayed. So the video is loading. The loaded video will now displayed. After that, the frame conversion process is employed. So in the frame conversion process, the input video is divided into number of frames presented in the videos. So here we have just displayed 50 frames from the total videos. That is, the videos has been converted into frames. We have just displaying it. After that, the pre-processing process is employed by employing filters to the videos, and this is the basic processes. Then after that, background subtraction is employed. So here the reference frames were subtracted from each and every frame of the videos, and based on that the regions were extracted. After that, the SVM classification combined with the morphological operations were employed in order to identify the object regions more exactly. So as we can see here, some of the object positions were missing. So while we employ SVM classification methodology, the regions were segmented more exactly. The process will take some time for the execution. After this results will be displayed. As we can see, the identified objects were optimized when compared to the previously detected object regions, and based on that now the tracking is employed. So while tracking, all the objects in the frames were tracked based on that. So this tracking continues till the complete end of the frames. So the tracking is employed by identifying the starting position of the objects and their height and width. So based on that, lines were drawn around them, and based on that the tracking process is employed. So all the objects in the videos were tracked as the result. So finally, the overall performances of the processes were measured in terms of accuracy and error rate. So the obtained accuracy and the error rate were plotted with comparison with the existing methodologies, and the values for the existing methodologies were plotted statically, and for the proposed methodologies the values were calculated, and based on this the drawings were done. So as we can see, in the overall process, the pedestrians were presented in the videos were continuously tracked all over the video frames, and based on that the overall performances of the processes were measured. Thank you.